Hello everyone. In this lecture, we will discuss gamma function and beta function. This gamma function and beta function are two special functions which are most important in evaluating the improper integrals. Of course, these are itself the improper integrals. Okay. If you think of the gamma function, you see the gamma function is given by gamma of n is this integral 0 to infinity e to the power minus x to the power n minus 1 dx, and your beta mn is this is your beta mn, right? So you see, because of the presence of infinite here, it is an improper integral, and when m is here smaller than 0, what will happen? This x will come to the denominator, so it is also a improper integral. That means the beta and gamma function are the improper integrals. So our concern is not to discuss the improper integral. Our concern is how these two beautiful functions helped in solving many important problems, especially overcome the improper integrals, and also it has tremendous applications while solving the multiple integrals. We will see one by one. So now let us discuss the gamma function. You see, as the definition suggested, it is your power n minus 1, right? It is your power n minus 1, limit is 0 to infinity, then it has to be gamma of n, means this power is just increased by your 1. If I ask you integral 0 to infinity e to the power minus x to the power 2 dx, and immediately I will say this is nothing but my gamma of 3, right? Similarly, here if I ask you integral 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1. So here m and n are positive, then only the convergence of this integral can be established. And here also this integral will converge when n greater than 0, right? We will discuss when n greater than 0, this integral will converges, and this integral will converges. Okay, so here the behavior of the integral depends upon n, here the behavior integral depends upon m and n. Now you see what happens here, it becomes here beta of this m minus 1 power, here it is increased by 1 m, and here this is n minus 1 power, here it is increased by 1, means it is beta mn. Okay, for example, I ask you integral 0 to 1 x to the power 2 1 minus x to the power 1 by 2 dxa. Okay, 1 by 2 dxa. So then what will happen? So this will be here, it is beta of this 2 will be here 3, and this half will be half plus 1, 3 by 2. Okay, then subsequently we want to correlate this beta function and gamma function. Let us now first discuss the properties of the gamma function. So let us prove gamma of 1 is equal to 1. You know, gamma of n is integral 0 to infinity e to the power minus x to the power n minus 1 dx. If you put n is equal to 1, then it will be integral 0 to infinity e to the power minus x dx. Okay, so you simply integrate it. It is of course a improper integral. Now the integration of e to the power minus x is e to the power minus x integral 0 to infinity e to the power minus infinity is your 0, e to the power 0 is your 1, so this is 1. So therefore your gamma of 1 is equal to your 1. Okay, so let us see next property. Come to next property, gamma n plus 1 is n gamma n. So what will be your gamma n plus 1? So gamma n plus 1 will be integral 0 to infinity e to the power minus x. This is being n plus 1, so it has to x to the power n, is not it? So now you apply the by parts of integration. Let it be my second function, it is my first function, you apply the by parts. So this is equal to first integral second minus e to the power minus x with the limit 0 to infinity minus integral of derivative of first, it is n x to the power n minus 1 into integral of second minus e to the power minus x dx. Okay, so you see, if you put infinite and if you put 0, e to the power minus infinity is 0 and here 0 into something is 0, so this integral will 0 here. So now what will happen to this integral now? This minus into minus plus, taking n outside, it is 0 to infinite, e to the power minus x to the power n minus 1 dx. So now this is nothing but the formula of the gamma of n. So this is n into gamma of n. Okay, n into gamma of n. So now we use this to show another important property. Gamma of n plus 1 is factorial n. You see, we can prove it. So as we see here, gamma of n plus 1 is n gamma n. So now apply this property again here. Okay, apply this property again here. So what is gamma n? Gamma n, it will be n into, this will be again n minus 1 gamma n minus 1. Again you apply the same property over here. So this will be n minus 1 and this will be again here n minus 2 and gamma n minus 2. If you go on repeat this property, if you apply again here, if you go on repeat this property, then it will be n minus 1, n minus 2, subsequently will come up to here 1, then finally gamma of 1. So now this is gamma of 1 is here 1, gamma of 1 is here 1. So this is here factorial n into 1 is factorial n. Okay, so provided n factorial permits here n in positive integer. Okay, so the moment n is not a positive integer, or n is not 0, if it is negative, we cannot find the factorial. Now if I ask you what is gamma of 5, it will say it is simply 4 factorial. If I ask you what is gamma of 10, you will say simply 9 factorial. So factorial permits here. If I ask you what is gamma of 3 by 2, okay, what is gamma of 3 by 2? Here factorial will not permit. What is the formula? Gamma n plus 1 is n gamma n. So we will break it. It will be half gamma half. Okay, so we will know what is the value of gamma half. Clear? So now let us know an important result. What is gamma of half? Here gamma of half is root over of pi. For at this right moment, you just recall it that gamma of half is root over of pi. Later on we will prove it. We'll prove it later. Okay, so now we'll use it. If similarly, if I ask you what is gamma of 9 by 2, I ask, means you go on decrease it. Okay, it will be 7 by 2 gamma 7 by 2. Then again here 7 by 2, you decrease it by 1, it is 5 by 2. Then here gamma of 5 by 2. You can continue it. So this will be 7 by 2, then 5 by 2, then 5 by 2 will be 3 by 2, and 3 by 2 then half, and it will gamma of half. Okay, gamma of half is your root over of pi. Later on we will prove it. So this is the outcome now. Clear? So this property, as you know, gamma n plus 1 is n gamma n. So that means what is your gamma of n? Gamma of n will be gamma of n plus 1 by n, for n is any real number. Now this property will be used. For n is any real number. But as you see earlier, gamma of n plus 1 is factorial n, for n is a positive integer. Now we'll use this to find many important results. If I ask you what is gamma of your 0 here. Okay, what is gamma of your 0 here? You see, if you put n is equal to 0 here, for n is equal to 0 here, your gamma of 0 will be gamma of 1 divided by 0. Okay, so it is infinity here. So therefore my gamma of 0 is my infinity. Okay, undefined, rather I can say undefined. If similarly ask what is gamma of minus 1, so gamma of minus 1, if you put n is equal to minus 1 here, then it will give you gamma of 0 by minus 1. It is again here infinity. Similarly, if I continue here, what is gamma of minus 2? It will also infinity. So continue in this way. So our conclusion is gamma of 0 or negative integer, right? Negative integer is here infinity or undefined. But now the question is, if I ask what is gamma of minus half, okay, gamma of minus half, you see it here. If you put gamma is equal to n is equal to your minus half, then it is gamma n plus 1 minus half plus 1 by n. So it will be here gamma of half divided by minus half. Gamma half is root pi, so this is your root over pi, and minus half here is minus 2, so this is minus 2 root pi. So therefore gamma of minus half is minus 2i's root over of pi. Okay, minus 2i's root over of pi here, minus 2i's root over of pi. So this important result will be used to solve many applications. Similarly, if I ask you what is gamma of minus 3 by 2, your gamma of minus 3 by 2 will be gamma of minus 3 by 2 plus 1 by minus 3 by 2, isn't it? So this is equal to gamma of minus half divided by minus 3 by 2. Gamma minus half you substitute here, so this will be equal to minus of 2 root pi into, this is reversely multiplied, 2 by 3. So this is equal to minus 2 by 3. So this is equal to 4 root pi divided by 3. Likewise, if I ask what is gamma of minus 5 by 2, it will be gamma of minus 5 by 2 plus 1 by your minus 5 by 2. You simplify it, it will be minus 8 root pi divided by 15. Now coming to another important property. This is gamma of n into gamma of n minus 1 minus n is pi by sine n pi. This is again one of the most important property. Okay, so you see, we'll just remember this property. If I put, suppose my n is equal to I put suppose here 1 by 6, then what will happen? It is gamma 1 by 6 into gamma 1 minus 1 by 6, 5 by 6. So this will be my pi by sine pi by 6. Sine pi by 6, sine 30 is half. So this is pi by half. So this is equal to 2 pi. Okay. Similarly, if I ask you gamma 1 by 4 into gamma 3 by 4, means you put n is equal to 1 by 4. It will be here pi by sine pi by 4. Sine pi by 4 is 1 by root 2. Pi by 1 by root 2. So this will be here root 2 pi. So now let us use it to see whether gamma minus half, as you already proved, gamma minus half is here minus of 2 root pi. So whether this formula will give you this or not, you see, gamma n into gamma 1 minus n is pi by sine n pi. If I substitute n is equal to my minus half, okay, then it is my gamma of minus half into gamma of 1 plus half, 3 by 2 will be here pi by sine minus pi by 2. So what is your gamma of minus half? So gamma of minus half is here, this gamma 3 by r2 will come to right hand side. So it is pi by sine of minus theta minus sine theta, it is your minus 1. Okay, into 1 by gamma of 3 by 2 is my half gamma half. If you simplify it, so if you solve it here, gamma half is root pi. So now this is to come to the numerator. Minus twice pi root pi cancelled. So it is twice root over of pi. Okay. So this property is okay then. This property is okay then. Okay. Now comes to the beta function, right? The beta function we will see. Already I have told you above what is the beta function, and we will discuss the property. This beta function is here integral 0 to 1 x to the power 1 minus m and 1 minus x to the power, this is n minus 1, this is n minus 1 d. So this dx, it will be equal to here beta of, as I have told you, this will increase by 1, so m, and this will increase by 1, it is your n, right? So now likewise we will see the important properties of the gamma function. Property number 1, beta mn is beta nm. Let us prove it. This property is called the symmetry property. Okay, let us prove it. So here beta mn is this. Now you put 1 minus x is equal to here y. This 1 minus x is equal to y, right? So whenever x 0 to 1, 0 less than x less than 1, for 1 it is 0. What happens to your y? 1 less than y less than 0, right? So now differentiate it. What happens to your dx? Dx is your minus dy. You substitute this thing over here. So this will give you integral 1 to 0. 0 to 1 becomes 1 to 0 here. Then x becomes, what happens to your x? X is here 1 minus y. It is 1 minus y to the power m minus 1. And it is here y to the power n minus 1. It is minus dy. So minus of dy. So this will equal to minus 1 to 0 becomes 0 to 1. And bringing this to first y to the power n minus 1. 1 minus y to the power m minus 1 dy. So I write y or x, it is immaterial. It is 0 to 1. X to the power n minus 1 into 1 minus x to the power m minus 1 dx. Definite integral is independent of the variable. So is it not here the n first then m? Is it not here beta nm? So therefore what we conclude? We conclude here beta mn is same thing as beta nm. Okay. Coming to another important property, beta mn is twice integral 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2n minus 1 theta. Okay. So unless we know this proof, sometimes we may forget the property. So once we know the proof, then we will get the result instantly. So you see how I can prove it. So let us prove it. As you know, beta mn is integral 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx. You put here x is equal to sine square theta. You see, when x 0, sine 0 is 0, theta is 0, theta is here 0, right? When x is here 1, for which value of sine it is 1? It is pi by 2. So when 0 less than x less than 1, theta will varies from 0 to pi by 2. So now what happens to your dx? If you differentiate it, sine square theta derivative is 2 sine theta, x square is 2x, again sine theta, chain rule, is here cos theta. So let us substitute this here. So therefore this is equal to 0 to 1 becomes 0 to pi by 2, and x square, x means my sine square to the power m minus 1, and 1 minus sine square is cos square theta to the power n minus 1. Again here 2 sine theta cos theta, bring 2 here, it is sine theta cos theta d theta. Let you simplify it. So this will be twice integral 0 to pi by 2 sine the power is 2m minus 2 and plus 1. So it is 2m minus 2 and this plus 1 theta. Similarly cos 2n minus 2 plus 1 theta d theta. So this will be twice integral 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2n minus 1 theta d theta. So this is important. So now we establish beta mn is this. Now we come to another important property here. We just have a little bit of workout here. So if you put 2m minus 1 is equal to p and 2n minus 1 is equal to q, right? Then you simplify it. What will be your m? M will be p plus 1 by 2, and what will be your n? N will be q plus 1 by 2, is not it? So what happens to this integral? Twice integral 0 to pi by 2 sine to the power p theta into cos to the power q theta d theta. So d theta. Now it is your what? It is your beta mn, right? This is another important formula. Therefore I can say your integral 0 to pi by 2 sine to the power p theta into cos to the power q theta is half beta mn. Okay, so you see this is a standard formula. In many integrations you might have seen this type of integral, which is lengthy approach by previous means, now using the beta function, and finally this beta function will be converted to a gamma function in a interrelation formula, and the formula between beta mn and gamma mn is, the formula is like this. So it will be half, this is gamma of m into gamma of n divided by gamma of m plus n. So this is the relation between beta and gamma function. So I can tell you here another important property, that is relation between beta and gamma function. Here beta mn is gamma m into gamma n divided by gamma m plus n. Sorry, yes, it is gamma m plus n. It is gamma of m plus n. So this is another relation. Okay, so now already we read the properties of gamma function. Now this type of integral converted to a beta function, then beta function is converted to a gamma function, and we apply the properties. Here we apply the properties of gamma function, okay, to get the answer, So let us see one application here. So here what is your m and n? Here m is p plus 1 by 2, right, and n is q plus 1 by 2, right? So we rewrite the formula again to have a clear understanding. So as we see, sin p cos q is half beta mn, where m is this and n is this. So I write in terms of p and q. So it is half beta p plus 1 by 2 and it is here q plus 1 by 2. Now if I apply the relation between beta and gamma function, half is there, it is gamma of m means p plus 1 by 2 into gamma of n means q plus 1 by 2 divided by gamma of m plus n. So this is gamma of p plus q plus, here 1 plus 1 is 2 divided by 2, right, this. So this will be, we can write it, gamma of p plus 1 by 2 gamma of q plus 1 by 2 divided by 2 times gamma of p plus q plus 2 by 2. So if I ask you to evaluate one integral, so now you see its application here. If I ask you to evaluate this, okay, such type of many integrals you have studied earlier in your 12th class, but you see if this power is some 23, 25, then so what to do? It is your half beta of m p plus 1 by 2, 3 plus 1 by 2, comma 5 plus 1 by 2. So this is here 1 by 2 beta 2 and it is 3. Now apply the relation between beta and gamma function. This is beta mn is gamma m into gamma n divided by gamma m plus n, gamma m plus n, and this 2 is there. Now apply the properties of gamma function. Gamma n is factorial n minus 1. Gamma of n is factorial of n minus 1, is not it? So you apply this. So this is 1 factorial into 2 factorial divided by 2 into 4 factorial. So this is equal to 2 by 2 into 4 into 3 into 2, is not it? So this is equal to 1 by 24. If I ask you to evaluate this, then you see here, you apply the properties here. This is half of beta of 4 plus 1 by 2, 4 plus 1 by 2, comma, this is 6 plus 1 by 2, right? So this is half beta of, this is 5 by 2, comma, 7 by 2. If I remind you, this integral is quite lengthy by the previous method you read in your 12th class. So now you apply the properties of relation between beta and gamma. So half is there. This is gamma of m into gamma of n divided by gamma of m plus n. 7 plus 5, 12 by 2 is 6. Okay. So now already I have told you how to evaluate it. So this is gamma 5 by 2 means it is 3 by 2, 1 by 2, gamma 1 by 2, and here 7 by 2 means 5 by 2, then 3 by 2, then 1 by 2, gamma 1 by 2, and divided by this 2 is there, and it is 6 factorial, and gamma is, you know, it is root pi. So this is here 3 into 1 into 5 into 3 into 1 divided by this is 5 factorial divided by 2 to the power 5. This is 2 to the power 6, again 2, and into 5 factorial, it is root pi into root pi is your pi. You should solve it. Okay. So if you are asked, suppose integral 0 to pi by 2, 0 to pi by 2 sine to the power 6 theta d theta, you just recall the plus 2 idea. What you did? Sine square x whole to the power 3. This is 1 minus cos 2x divided by 2 whole to the power 3. In that way, the lengthy approach, then we apply again the definite integral. But here you see, it is quite easy by using this beta and gamma function. So this integral will be equal to 0 to pi by 2 sine to the power 6 theta. Now cos to the power 0 theta. Cos to the power 0 is your 1, is not it? So now you convert it in terms of the beta function. It is half beta of 6 plus 1 by 2, 7 by 2, comma, 0 plus 1 by 2 half. Then you apply the convert it into the gamma function. So this is 1 by 2 gamma of 7 by 2 into gamma of half divided by gamma of 4. 7 by 2 plus 1 by 2. So this is gamma 7 by 2 is 5 by 2, 3 by 2, 1 by 2 into gamma half is root pi. This 2 is coming to the denominator. F gamma of 4 is your factorial 3. Okay, you just solve it. Now if I ask you one more complicated integral, you see, if I asked you to solve it, you can recall also in your plus 2 or 12th class, it is a quite complicated integral and quite lengthy here. So by using the gamma function and beta function, it is quite easy now. So root over of tan means sine theta divided by cos theta to the power half d theta. You see, it is quite easy now. So 0 to pi by 2 sine to the power half theta into cos to the power half theta d theta, is not it? Now it converted to the gamma function. So this is half beta of, this is half plus 1 by 2. This is cos in the denominator, so it will be a minus half. So this is beta half plus 1, 3 by again 2 again by 2, 3 by 4, comma, it is minus half plus 1 by 2 again. So it is here 1 by 4 here, 1 by 4 here. Okay. So you convert it now. So this is half here gamma of 1 by 4 into gamma of 3 by 4 divided by gamma m plus n. Gamma 3 plus 1, 4 by 4 is your 1. Already I have told you how to overcome it. Okay, so already I have told you earlier properties of gamma function. So what is this value? So this value is now, this is your half, this is root over of 2 pi, and gamma of 1 is 1. So this will be pi by root 2. This will be your pi by root 2. So you see how easy to evaluate this complicated integral by using the beta function and gamma function. Now we prove the most important properties of gamma, that gamma half is equal to root pi. Okay, you see already you know this. Now the moment I put p is equal to q is equal to 0, this will be my 0 to pi by 2. Okay, sine to the power 0 theta, cos to the power 0 theta. So this will be my beta half. Okay, now apply the properties of the gamma, convert it. It is gamma half, gamma m, gamma n by gamma m plus n, gamma half plus half, is not it? So this is equal to gamma half, this is whole square, and gamma 1 is 1, and in the left hand side, it is my twice, it is d theta here. So this is 1 and this is 1, is not it? So this is only 0 to pi by 2 d theta only. So this implies my left hand side is theta twice 0 to pi by 2. Right hand side is gamma half square. So what is my left hand side? Now it is 2 into pi by 2 is my gamma half whole square. So this cancelled. So what is my gamma half? So gamma half is root over of pi. So this is proved, right? So this is proved. Is it not that easy? However, there is an other approach to prove this by using the double integral. Okay, so at this moment this proof is okay then. So now further properties of this beta function. So already I have told so many things based on this property, and this property we have already discussed. Now coming to some other important property. Property number 3, integral. Now you see another important property, integral 0 to infinity. Mark it, this is infinity. Okay, x to the power n minus 1 by 1 plus x to the power m plus n, right? Dx is here beta mn, again here beta mn, right? This is another important property. If I tell its consequence, so this is another important property. You see this is infinity. Okay, and in the properties of the beta function this is 1 here. However, we can establish it. So the same thing, this is your n plus 1, this n is increased here by 1 here. Okay, so now what will happen to this? So this will be beta of, so this is being 3, this will be your 4. Okay, now this should be your m plus n, we get n is 4, so m plus n is equal to my 10 here, n is my 4 here, n is here 4, n is equal to 4 here. So what is m now? So m is equal to your 6 now. So this is your 6. Okay, so this is equal to beta 6 4, is not it? So then you can apply it. This is your gamma p plus 1 by 2, this is your gamma m into gamma n divided by gamma m plus n, 6 plus 4, is not it? So this is equal to 5 factorial into 3 factorial, and gamma 10 is your 9 factorial. Clear? So I can apply this property to solve one more problem. Suppose you are asked to evaluate this integral. Okay, you are asked to evaluate this integral. So now you just split it. So this is 0 to infinity x to the power 8 divided by 1 plus x to the power 24 dx, then minus this is x to the power 8 plus 6 x to the power 14 divided by 1 plus x to the power 24 dx. Now you integrate it. You see now how I am using. This is my n minus 1, this is my n minus 1, and this is my m plus n, and this formula will give you beta mn. So this will give you beta of n. What is n? It will increase by 1, 9. Then 9 plus what is 24? Okay, so it is here 15, is not it? Because m plus n is 24. Now if 15 plus 9 is 24, and accordingly here this is 14, means it is my beta of, it is 15. 15 plus what is 24, right? 15 plus what is 24? It is your 9. Clear? So your beta mn is beta nm. So this is equal to your beta 15 9 is same thing as beta 9 15, is not it? Beta mn is beta nm. Beta nm is beta mn. So this and this cancel. So this is equal to 0. You see, the integral seems to be complicated, right? However, using this beta function and gamma function, this is quite easy now. So now coming to the proof of this property. What is the property? Beta mn is 0 to infinity x to the power n minus 1 by 1 plus x to the power m plus n, okay, dx. But because of the symmetry also if one is going to write it 0 to infinity x to the power m minus 1 by 1 plus x to the power m plus n, then also it is okay now, because of the symmetry property. Beta mn is beta nm. Okay, now if you want to establish this property, I will not prove the details, I just tell you the hints to prove it. So how to prove it? You know, beta mn is integral 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Now if you put x is equal to 1 by 1 plus y, okay, then you will able to establish it. What will be your dx? Derivative of this is minus 1 by 1 plus y square, is not it? Now when x varies from 0 to 1, and what will happen to your y? Y will varies from infinity to your 0, right? And this integral will be converted to 0 to infinity, because you have a negative sign here, right? This integral will converted to your 0 to infinity this, and finally you will get that. Okay, if you simplify it, it will get 0 to infinity x to the power n minus 1 by 1 plus x to the power m plus n. Okay, so this is proved. Clear? Now recollecting the properties together, just we recollecting all the properties together, just I remind you here. Gamma of n plus 1 is n gamma n, right? N is a real number, and the moment n is a positive integer, it is your factorial n, is not it? So accordingly, what is your gamma n? Gamma n is gamma n plus 1 by n. Clear? What is gamma half? Gamma half is root pi. What is gamma of 1? Gamma of 1 is 1. What is gamma of 0 or negative integer? It is your infinity. And what is your gamma n into gamma 1 minus n? It is your pi by sine n pi. Similarly, we recollect all the properties of the beta function, and this gamma function will converge. And what is the definition of gamma function? 0 to infinity e to the power minus x to the power n minus 1 dx. It is your gamma n, and this gamma n will converge, right? When here n is greater than 0, right? Likewise, we recall the properties of the beta function. Likewise, we recall the properties of the beta function at a glance. It is 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, and it will converge when mn positive, both positive. Okay, and we see that beta mn is beta nm, and here beta mn is equal to twice integral 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta, and we further simplified it to get half beta p plus 1 by 2 q plus 1 by 2 is integral 0 to pi by 2 sine to the power p theta cos to the power q theta d theta. Okay, then we know the relation between the beta function and gamma function. Beta mn is gamma m into gamma n divided by gamma m plus n. Then coming to the fourth property, here beta mn is equal to integral 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n, or it is same thing as integral 0 to infinity x to the power n minus 1 by 1 plus x to the power m plus n. Okay, and one more property we may use while solving the problem. Beta mn is equal to integral 0 to 1 x to the power m minus 1 plus x to the power n minus 1 divided by 1 plus x to the power m plus n dx. So don't be confused, it is your 1. Okay, don't be confused. So let me to tell you the hints of this proof of the last one. Somehow we will use it while solve the problems. So exactly the proof is not required, but don't not to confuse the why it is infinity, why it is 1. Okay, so I just elaborate it. 0 to infinity, I split it in the previous property. You know, beta mn is 0 to infinite x to the power m minus 1 this. So now 0 to infinity, I split it 0 to 1 and plus 1 to infinity. Now this is the part of this property here. Now I work on this property. It is 1 to infinity. I put this, after substituting this you will get it. So therefore adding this and this, we will get here beta mn is nothing but this is, you replace x by y. The definite integral is independent of the variable, so it is 0 to 1 x to the power m minus 1 plus x to the power n minus 1 divided by 1 plus x to the power m plus n. So these are the most important properties of the beta and gamma function. Somehow we have solved examples. Okay, in our future lecture, we will see some important problems at a glance. Okay, some important problems at a glance. To solve all these problems, you should thorough on these above properties. Okay, so the video is getting lengthy, we will close it here. If you find this lecture is interesting, you subscribe to this channel so that the next video when uploaded, it will come to your screen. And certainly I will discuss many important problems in my next lecture on this beta and gamma functions. So thank you all. Let us close it here.